Welcome back. So far this unit, we have learned how to use the law of sines. We've learned how to use the law of cosines to find an angle or a side. And now what we're going to move into is finding the area of a triangle. And you might remember way back when that the area of a triangle is equal to 1/2 times the base times the height. And that kind of assumes that you know what the height is going to equal to. And that's kind of tough because you need that right angle to measure the height. So it was kind of coincidental that you were able to find the height every single time, but you won't always have the height given to you. This is where trigonometry comes in. So I'm going to show you how to derive the formula for the area of a triangle using trigonometry, and then we're going to use that the rest of this assignment. So in this diagram below, we're going to derive the formula for the area of the triangle. We're going to start with just area equals 1/2 times the base times the height. And I think it's pretty easy to recognize, at least from this triangle, that the base is going to be here. Technically, you could make the base any of these sides that you want, just rotate it around and flip that on the ground, but I'm just taking the one that's on the bottom. In this case, it's labeled B. So we have our area is equal to 1/2. I'm going to call that base B. Now I need to find the height, and this is where we have to do a little bit of legwork here. So I want to find this height right here. It makes a 90-degree angle. So this, for me, is going to be my height. How could I do that? Well, hopefully you look here and we have a right triangle. This is our opposite side. I'll call that O. And then this is our adjacent side, or H. Do you remember which ratio you can use to solve for that? O and H, that's going to have sine. Because remember, for this height, I'm going to have the sine of theta is equal to the opposite over the hypotenuse. And in this case, this opposite side, so I'm going to rewrite this now as sine of theta equals that opposite side we're just calling h. That's our height. And then the hypotenuse, that's this one, is going to be a. So if I were trying to solve for the height, I'm trying to get this height all by itself. We have to multiply both sides by a, which now leaves us the height of that triangle is equal to a times sine of theta. So if we replace the height with a sine theta, it would end up becoming area equals 1/2 times the base times a sine theta. And this is really close to the final answer. I'm just going to rearrange things to show you the way that you see it in a formula booklet. We get area equals 1/2 AB sine C. So that theta was just angle C, so I'm calling it C. And I rearranged the A and the B, so they're alphabetical. But that is the formula for the area of a triangle. And that will work for any triangle. As long as, similar to the law of cosines, what do you need to remember about this formula? The C, that capital C, is the included angle. So to use this formula, we need to have side angle side once again. So we need two sides along with the included angle in order to use this formula. Now let's go do a couple examples now that you've seen how the formula works. First example, find the area of this triangle below. So we have side angle side. We have a side, included angle, and a side. So here's our formula. Area equals 1/2 AB sine C. Remember, our A and B are just going to be the two legs that come off of the angle. So it's going to be 7.8 times 8.4 times sine of C. And in this case, C, it's not that C over here. C is the included angle, which happens to be 82.7 degrees. Whoever invented this formula didn't care about where your letters A, B, and C were in the picture. C, remember, that's the included angle. That's the angle that you were looking at. So we're going to take 1/2 and multiply it by all of those things over there and just punch it in a calculator. Make sure you're in degree mode once again. And we get an area of 32.5 centimeters squared. Go ahead and try the next one on your own. So you're going to pause the video. I added a little distractor number in there for you, so you won't use all the numbers in the picture. But go ahead and pause the video. Make sure you understand how to use the formula, and then we will go backwards a little bit. All right, did you get an answer of 26.7 inches squared? If so, give yourself a pat on the back. Nice job. Remember for that one, if that was the angle you're looking at, this is your A and your B. That 8, you don't need that to find the area. So A and B were 6.8 and 9.4. Just throw them in the formula, and you got 26.7. Now we're going to go backwards a little bit. Now I'm giving you the area of the triangle, and I'm asking you to find some missing information about the triangle. So let's just set up our formula. We know that the area of a triangle is equal to 1/2 times A times B times sine of C. And in this one, it says that the area is 50 square centimeters. So I can replace the area here with 50 equals 1/2 times, I need A and B. So A and B, it doesn't really matter which order you put them in. I'll just call it 8.2 and 13.7. And then it's still times sine of C. Now, if I'm trying to solve for C, I have to get C all by itself. So I'm going to take all of this here, and I'm going to multiply them all together. So if you multiply 1/2 times 8.2 times 13.7, I believe that gives you 56.17. So simply multiplying those together. Now we still have to get rid of that 56.17, so let's divide it on both sides. So I'm going to divide both sides by 56.17. And we are left with 0.8902 equals sine of C. Now hopefully you remember from earlier in class that to get rid of this sign, we have to inverse sine it. So if we inverse sine of 0.8902, we end up with 63 degrees. I'm rounding a little bit liberally here, but we're going to say 63 degrees. However, let's go back to that question. It said, find the two possible values for theta. Remember, when you inverse sine something, they give you the acute angle, but it is possible, maybe my triangle wasn't drawn to scale, that you could have an obtuse angle. Do you remember how to find that one? Think of your unit circle. Here's our unit circle, and we had a sine value of 0.89. That was way up here, a y-coordinate of 0.89. And that led us to an angle of what we just found, 63 degrees. So that angle is 63 degrees. However, there is one more triangle or angle that has the same sine value, and it would be over here. If this is 63 degrees, subtract it from 180, and we get another possible angle of 117 degrees. So, or 117 degrees. if you make some assumptions from the picture, it looks like that angle is acute, so it looks like it would probably be 63 degrees, but technically there are two possible answers. You could have had a triangle. Don't draw this on yours, I'll erase in a second. But this could have been the 13.7, and you could have had it going this way. Let's draw it a little more accurately. This way, and that could have been 8.2. And that triangle over here would also have the exact same area if this was 117. So that triangle would also have an area of 50 square centimeters. Go ahead and try the next one on your own, and then come on back when you're done, and we will reveal the answer for you. Hopefully, you ended up with 22.7 centimeters. Start with your formula. You can replace the area with 324. Plug in your A. We don't know B. Plug in your C. Then what you had to do was multiply 1/2 times 33.9 times sine of 57.4. Type all that into calculator, multiply them together, and you get 14.28. Divide both sides and you're done. One last example, and this is going to be more similar to what's on your assignment for this week. The area of the triangle is 59.8. Find the missing side length given that theta is obtuse. So a lot of stuff going on here. We have area equals 1/2 AB sine of C. If we know that the area is 59.8 equals 1/2, then we look at our triangle. Our A and our B are 11 and 12. So times 11 times 12 times sine of C. We can simplify the right side by multiplying, and that becomes 1/2 of 12 is 6. 6 times 11 is 66 sine of C. You could divide both sides by 66, and you end up getting 0.9061 equals sine of C. And then if you take inverse sine of 0.9061, you end up getting 65 degrees. However, if you look at this angle, it's not a 65-degree angle. It tells you in the problem, it's given to you that theta is obtuse. So remember, your calculator finds the acute angle. To find the obtuse one, we have to subtract from 180. And we get an angle of 115 degrees. So now we know that this theta is 115. And you might think, hooray, you're done with this problem. But the question actually asked to find the missing side length. Here's the missing side length over here. So now what we have is side, angle, side. So if we have side, angle, side, we can now use the law of cosines to find that missing length. So I'll go ahead and set that up for you. We have c squared equals a squared plus b squared minus 2 times a times b times cosine of c, which now we can replace with 115 degrees. You're going to go ahead and type all of that into your calculator, and it's going to simplify to be c squared equals 376.6. And finally, to find that missing side, we have to square root it. And if you square root both sides, we end up with 19.4. I'm assuming it's centimeters, hopefully. Yes. So that last side is 19.4 centimeters, and that kind of matches up with the picture here, 19.4. So that's going to be more of what your assignment is like. You're going to have to decipher which formula to use. Do you have to use the area formula? Do you use law of sines? Do you use law of cosines? So you got to have a little bit of creativity there. So enjoy the assignment this week, get that done, and then enjoy the rest of your weekend. Thanks for stopping by, everyone.